Okay, now we learn about balancing chemical and redox equations. Balanced chemical equation given information about the amount of reactants requires and the amount of product formed in a chemical reactions. So we look at the general equation given. So the x, y, z, and w represent the stoichiometry coefficients, which means that it's the numbers of moles involved in a chemical reactions. So two methods in balancing the chemical equations. So we have the first method, which is inspection methods. So normally for chemical equations. The second method, which is called ion-electron methods. So normally used for redox equations involving ions in the reactions. So now we look at the first method, which is inspection methods. So in balancing chemical equation using inspection methods, the following step is applied. So we have three steps here. So the first step, write down the unbalanced equations, write the correct formulas for the reactants and products. Second step, balance the metallic elements if any, followed by non-metallic atoms. Balance the coefficient of hydrogens and oxygen atoms. So the third one, check to ensure that the total numbers of atoms of each element is the same on both sides of equations. By using inspection methods, we balance the given equation. First, write down the unbalanced equations. C2H6 plus O2 give us CO2 plus H2O. Balance carbon first. You have 2 carbon on your left and 1 carbon on your right. We balance the carbon by put coefficient 2 in front of carbon dioxide. Then we balance the hydrogen first, not oxygen, because oxygen come up twice in product. You can check the product here. So you got oxygen in carbon dioxide and oxygen in H2O. So you got 6 hydrogen on the left and 2 hydrogen on the right. So you put coefficient 3 in front of H2O to balance hydrogen. Lastly, we balance the oxygens. On the right, you got 7O. Why got 7O? 2 multiplied 2 is 4. 4 plus 3 is 7. So we put coefficient 7 over 2 in front of oxygen gas. The equation can be simplified by multiply 2. So you can get 2 more of C2H6 plus 7 more oxygen gas give us 4 more of carbon dioxide plus 6 more of H2O. We can double check our answer. So you can see for reactants, we have 4 carbons, 2 multiplied 2, 4 here, so it's 4 here. Then your hydrogen is 12, 2 multiplied 6, 12, 6 multiplied 12 is 12. Then we check oxygens, 7 multiplied 2 is 14, 4 multiplied 2 is 8, 8 plus 6 is also 14. So we can make sure the equation is balanced. A practice exercise. Students can try to balance the following chemical equations. Balancing redox equation, oxidation, loss of electrons, oxygen number increases, reduction, gain of electrons, oxygen number decreases. You can use the abbreviation OIL. OIL stands for what? OIL stands for oxidation is the loss of electrons. Reduction is the gain of electrons. Redox reaction is a reaction where both reduction and oxidation reactions occur simultaneously. By looking at the given diagrams, element X transfer or shift electrons to Y. So X lost electrons, X is oxidized, X undergo oxidation, so it's a reducing agent. X increase its oxygen number. Y gain electrons, so Y is reduced, so Y is called oxidizing agent. Y decrease its oxidation number. By looking at the given example, we are able to determine which species undergo oxidation and which species undergo reductions. So we link zinc and zinc 2 plus, zinc with zinc 2 plus. So zinc is 0, zinc 2 plus is positive 2. So you can see that the oxygen number increased from 0 to positive 2. So oxygen number increase. So means that zinc undergo oxidations. So means that zinc is called reducing agents. Then look at copper 2 plus to copper. Copper 2 plus, the oxygen number is positive 2. Copper is 0. So you can see that the oxygen number decreased from positive 2 to 0. Oxygen number decreases. So means that copper 2 plus undergo reductions. Since that copper 2 plus undergo reductions, so it's called oxidizing agent. Now we look at the next example. So Cl2 will link with the KCl, just take the Cl minus only, because you have K plus and Cl minus. So Cl2 is 0, and Cl here is Cl minus. So from 0 to -1 means that oxygen number decrease. Oxygen number decrease means that Cl2 undergo reductions. Since that Cl2 undergo reductions, so Cl2 is called oxidizing agent. Then we link between KBr with Br2. We only take the Br only in KBr. So we have K plus and Br minus. So -1 for Br here, then Br2 here is 0. So you can see that the oxygen number increase from -1 to 0. So means that the Br minus undergo oxidations. So the Br minus here is called reducing agent. So together with the KBr lah. Then we look at the next example. So here we have manganese. So NO4 minus, the oxygen number for manganese here is +7, and here is +2. So you can see that the oxygen number decrease from +7 to +2. So oxygen number decreases. So it means that the NO4 minus, the manganese here, undergo reductions. So since it's undergo reduction, so it's called oxidizing agents. Then look at Fe2 plus with Fe3 plus. So here we have Fe2 plus is +2, Fe3 plus is +3. So you can see that the oxygen number increase from +2 to +3. So it means that Fe2 plus undergo oxidations. Since the Fe2 plus undergo oxidation, so it's called reducing agents. Here we don't take into consideration the 5 more, because we just look at the species here. Okay, the species Fe2 plus with Fe3 plus. Balancing chemical and redox equations. We're using the second method, which is ion-electron methods. We have two medium, which is acidic medium and basic mediums. Now we learn about the acidic medium first. Step 1, divide the equation into two half equations. Step 2, for each half equations, balance all elements other than hydrogen and oxygens. Balance oxygen atoms by adding H2O. Balance hydrogen atoms by adding H+. Balance the charge on both sides by adding electrons to the side that has a more positive charge. This one we can simplify as EOH charge. Then look at step 3. Combine both half equations. Multiply the half equation by appropriate integers to make electron gain equals to electron loss. Cancel any species and electrons appearing on both sides. Balancing redox equations by using ion-electron methods. Previously we learned about acidic medium, now we learn about basic medium. So step 1 and step 3, balance the equation as in acidic medium. We have addition step for basic medium. With step 4, determine the numbers of H plus ion in the acidic equations. Add both sides of the equation the same numbers of OH minus. The number of OH minus add in must same with the number of H plus in equations. So combine H plus and OH minus to form H2O. Cancel any H2O you can. Thank you for watching.